Thank you. So my name is Stephen. I work here at Google on remote execution, specifically on the remote execution cloud service that we showed this morning. But I want to talk to you a little bit today about, first of all, what is remote execution and caching? How does it work? Why does it give such a great performance improvement? And what are the other benefits of it? And then second of all, the specific Google Cloud service that we're offering, and some general guidelines for how to make your build work with remote execution, how to make your build work with remote caching. Those largely apply to any remote service, remote build service, although there are a few specifics to the Google service as well. So to start out, what are remote execution and caching? I can tell you a lot of technical things about them, but at root, this is about a tool that allows you to run more tests, run your tests faster, run them more often, and that leads to improved software and improved developer productivity. So we had a pilot program internally with Android Studio where they started trying out remote builds and just to see what effect it had on their workflow. And the lead we were working with said, it improved our overall quality by enabling our team to run more pre-submits, and it increased our pre-submit test coverage by more than 4x. That's a great benefit. It's really helping their team. They're able to run their pre-submits on, or they're able to run pre-submits and post-submits on every commit now, whereas before they had to do a rolling system and they had to do it on these giant 32-core machines that were a pain to manage and are very expensive, and it was actually hard to get enough of them to meet their volume. So it's really worked very well for them. So technically, remote execution and remote caching are two different things, related things, but different. Remote execution allows you to distribute your build and test actions across potentially hundreds of cores across the cloud, whereas remote caching allows you to avoid doing the same work twice, whether that's the same developer trying to build the same thing twice, or your CI system that's already built something, and then you sync that to your local tree and you want to build it. That all exists in this remote cache in the cloud, and you can just pull down the results. And when you put them together, they lead to faster build and test cycles and overall better software. So looking at the specifics of how this works, as I've already said, remote builds are faster because they're not constrained by local resources. So if you have this typical Bazel workflow, you have your developer there on the left. This could be an individual developer. It could be a node in your CI system, anything really that runs a Bazel command. You invoke Bazel, builds the action graph, checks its local cache, checks the remote cache, et cetera, and filters out what it really needs to run, and then it distributes that across all of your local cores. In this case, I have 8 here. Maybe it's 16. Maybe you're really lucky and have 32 or 64 cores, but it's a very finite and small number. And if you're trying to run a lot of things, it's slow. So when you talk about the cloud, though, as I showed this morning, you can run on 500 cores. You can run on 1,000 cores. You can distribute as much parallelism as your build graph can handle. And that leads to much faster build times. Second reason remote builds are fast, or remote builds are beneficial, is because it's much more efficient to have a shared pool of cloud resources than to have a bunch of individual resources locked up on individual machines. So if you look at a picture of your organization, again, these could be developers, could be CI machines, you can see that everybody here has a nice 16-core machine. Most of the time, about 15 and a half of those cores are sitting idle because you're just running your editor and maybe some browser tabs, things like that. So your machine is really over-provisioned for 90% of the time, except when you want to go do actual work, when you want to build things and test things. And then suddenly 16 cores is not enough. Your machine is under-provisioned. So you have this situation where it's really hard to optimize, and it's hard to know what the right cost trade-off is for how to distribute these cores across developers. But again, if you have this cloud pool of cores, we have this developer who's running Bazel locally. All the other developers are running Bazel locally as well. Your CI system, we have cloud build there as well as Jenkins. Could be BuildKite, could be any of the normal CI paths. All of those share the same pool of cloud cores. And that means that because those build loads are very spiky, most of the time your machine's sitting idle, you can really bin pack very well across those cores. You can keep all those machines busy, but you can keep everyone's build fast at the same time. So that looks roughly like this. You've got developers who now have 4-core machines. Still more than enough power for them to do their coding, email, et cetera. But then when they need the real power of the cloud, they can tap into that very quickly and easily. Third reason remote builds are beneficial, they're more correct because the sandbox remotely is more comprehensive. So the Bazel sandbox is a great tool. It's a really helpful tool. I really recommend running with it if you're doing your builds locally. But it's not perfect, and it's not foolproof. A lot of this has to do with the underlying tools that Bazel invokes. So for example, if you build with GCC, GCC has built into that binary a path traversal where it will look into well-known paths for system headers. So that local state of your system can still leak into your build, no matter how hard you try. And Bazel locks down a ton of things, but again, it's not perfect. Remote execution, you're running on a remote machine. You're running, in our case, inside a Docker container that has a well-defined hash. Everything is very traceable and trackable. So it's a very tight sandbox. It's really hard for something in your local machine to leak into that remote system. And I think this is a really interesting topic. There are a lot of ins and outs. Nick Lopez, who's right over there, is going to give a whole talk about this tomorrow afternoon. So I highly recommend attending that, ways in which you can improve the sandboxing of your build and you can make your build more hermetic. Finally, remote builds are beneficial because the remote cache makes everyone's build faster, not just one person's build. It's a shared resource. It's spread across your whole company, your whole CI system. Anything that does a build or a test can leverage this system. So again, we go back to this diagram. You see the individual developer on the right, or on the left rather, the pool of developers and the pool of cloud cores on the right. But then you also have this cloud cache up on the top. And again, your CI system is accessing this. Your CI system is populating this. So you check in your code, the CI system builds it, tests it, uploads the results to the cache. Next person syncs the code to their machine, they build and test, and hey, the results are already there. So they don't actually have to do any actual work. That's already been done by the CI system. So in summary, just to look at the benefits of remote execution and caching, remote execution lets you run more things in parallel by using machines in the cloud. Remote caching lets you avoid duplicate work, and altogether that means a build that's faster, it's more efficient, and it's more correct. So to talk about this specific implementation of the Google Cloud Service, we call it remote build execution. I also use the term cloud build for Bazel. We kind of use both. So looking at this, we're built around this open source API. It's called the Remote Execution API, hence the name Remote Build Execution is our specific implementation of it. And the way that integrates with Bazel is what we call Cloud Build for Bazel. It's designed to be seamless. It's designed to fit with Bazel. It's designed to fit with Google Cloud Builder. So you can really use Bazel in the cloud entirely, or you can use it locally. But it is an open source API. We're not the only implementation. There are a couple open source self-hosted implementations that you can access and set up and run on whatever on-prem farm or anywhere you want to. Our particular offering is hosted, so we remove all the management overhead of managing machines and spinning them up and down and handling them if they get corrupted, need to be quarantined, things like that. There may be more. So there's the build farm project that is part of the Bazel build org and that George from Uber works on. There are a couple others, Build Grid, Build Barn. There may be more that I'm not thinking of right now. And the same thing happens on the client side. Obviously, this is BazelCon. We all use Bazel, but there are other client implementations as well. BuildStream is working on one. Someone from Pants got in touch with us recently. They tried running Pants against the cloud service and said, hey, this all just works. Great. So there's some level of interoperability between these, and you can mix and match pieces as well. In terms of this service, Google Cloud Platform Remote Build Execution. This is an alpha service right now. It is a fully managed cloud service. We handle spinning up all the machines in the cloud, spinning them, recycling them when they need to be, all those things. And if you need more machines, you can easily scale up. If you need fewer machines, you can easily scale down. And obviously, we have the shared build cache as well. So this service supports use both as a full remote execution and caching service, as well as a service that you can just use as a remote cache. Some of you may be using Bazel's remote cache on its own, either with something that you have on-prem or some other technology. You can use it this way with this service as well. If you're interested, we do have documentation as well as a survey that takes some basic information about your build, languages you're using, et cetera, things like that. I will make sure that these are publicly accessible so you can find that link later, or you can just come talk to me. So in terms of the results that we've seen, we've been working with a number of different customers over the past year or so. TensorFlow was one of our first customers. It says, this is from a quote from one of the leads. It says, we've reduced their average build times by 80%. It's gone from, about 45 or 50 minutes to about 5 minutes for the average build. At the same time, we've also reduced the dedicated CI hardware that they have. As I said, they can run on smaller machines now. They don't need 32-core machines. They just use little 4-core machines running in the cloud. So it's been a win-win, 80% reduction in hardware, 80% reduction in time. It's been great. In terms of other results, Android Studio is internally running their CI, their Bazel-based CI with this RBE service. As I said, it has allowed them to scale up and run builds, or run tests at every commit, run a lot more tests, and improve their test coverage. Alex talked this morning about Angular adopting RBE for Angular CI. I guess I'm maybe even underselling this a little bit. What I remember looking at was that their test times went from an hour to 15 minutes. It sounds like it may have even improved a little further. So that's great. Unless you think this is an internal thing only, where everything we're doing is a little bit different, we have a couple external customers as well. I can't mention them because, well, they're external customers. We don't want to mention them. But they have seen similar results, great build speed improvements, great scalability improvements. So it's been really successful as a pilot program. We're also starting to take some benchmarks with open source projects. So the methodology we've chosen is to try to simulate a CI workload. So we take a range of 50 commits from an open source repository, and we run them sequentially, one after another. We clear the local cache in between, so it simulates landing on a fresh CI machine, and just see what happens when we run in different configurations. First project we picked was Google's Bazel C++ libraries. You can see we went from about 88 seconds on average per build to 51 seconds using just the remote cache. And then when we added in remote execution, we went to 23 seconds. So it's a 40% reduction in overall end-to-end time of this 50 commit range using the remote cache, or about a 70% reduction using remote execution plus caching. So I want to talk a little bit about the process of how you get your builds to work with a remote build system. This has a few specific things for the remote build execution system, but it has a lot of generic things that apply to any system where you're suddenly moving your actions off your local machine and onto a remote machine. So the first decision that you need to make up front is whether you're interested in looking just at caching or whether you want to do remote execution plus caching. Why would you want to do one versus the other? So caching can provide a pretty substantial performance benefit, as you saw, 40% in the case of Bazel, maybe a little higher or lower depending on the project. And this works even for fairly small projects. Bazel builds are quite small. I think they take, as I recall, less than 5 minutes to do all their builds and tests. So even for them, we were able to provide a substantial benefit. And it's a much faster onboarding process because you don't need to change your build really at all. You just need to kind of capture the state of your local system, and that's it. And we can support more languages, more platforms with just the remote cache. So the current system is Linux only. Do we have any Windows developers out there? Anyone targeting Windows? A few, a handful. So the API itself is built to accommodate Windows. We've internally, we have a prototype that works with Windows, trying to figure out exactly what to do with that. There are some different constraints on licensing and compatibility and things like that that make it a little trickier. But you can use remote caching today, and then if the time comes when we do support Windows, you can upgrade to remote execution. Remote execution plus caching gives you the maximum performance benefit for large projects. That's what you saw with TensorFlow earlier. It's a really big project, lots of tests, lots of things to run. It also gives you the most protection because, again, you're running in this remote system, well-specified system. There's no chance of local dependencies leaking in. But the downside is that what we find when you move to that remote system is, well, maybe you were depending on some of those things locally. You've got to change your build a little bit. You've got to update some targets, things like that. So it takes a little bit longer. It takes a little bit more effort. So to walk through just the journey of onboarding for each of these, if you're interested in pursuing just the remote cache, the first thing you need to do is figure out the signature of your local system. So you're running these actions on a build or on a machine. Maybe it has a particular JDK. Maybe it has a particular version of Clang or GCC. Maybe you use sort, and sort is not necessarily stable across all Linux distros. So you want to capture the version of that you're using, things like that. So you need to figure out what you're using on your local system and distill that into some sort of cache silo key. So this is a way to identify the constraints of your particular system. Second thing you need to do is actually, obviously, set up the permissions on this remote cache. And then finally, you need to configure Bazel to use your remote cache. And the path we recommend is to deploy to CI first, because that's where you get the most value out of these builds. You're generally landing on a fresh machine, and pulling all the artifacts from that remote cache really delivers a lot of speed up. And then once your CI system is running well, you can roll it out to developers. And it's just a little bit easier path to work on CI, where it's a more tightly controlled, centralized environment. So this cache silo key. As I mentioned, this is all about the binaries, the system libraries, things on your local system that you're accessing. And again, that could be your local developer machine. It could be your CI host. The gold standard here is really something like a Docker image hash if you're running inside of a Docker container. But most of the time, that's not really the case. So you want to kind of look at what things are installed on your system and what things are used by Bazel, and put that into an identifier. For starters, you can actually just use a number, and if something breaks, then you can increment that number, and you get a fresh silo. As you can see from this diagram, the way this actually works is that it creates essentially an entirely separate remote cache. So systems that use one key write to one cache, systems that use another key write to a different cache. And that way you don't get any cross-contamination or someone polluting a cache with an invalid artifact. Second thing is permissions. So what we recommend for this is that you set up your CI system, which again is tightly controlled. You have centralized image management probably. You have very few people who have access to it, who have direct access to it, et cetera, as both a cache reader and writer. And then you set up individual developers just as readers. So again, you don't get somebody who fat fingers a command and corrupts your whole cache. So you just make those individual developers read-only, or give them read-only permissions. And then finally, configuring Bazel to actually run this. Bazel has a number of different flags you have to set. We do provide a sample Bazel RC. Another quick show of hands, who uses Bazel RC files versus just lots of things on the command line? Oh, right, good. So we provide this sample RC. You have to copy it and merge it into your existing Bazel RC or put it on your local system. But it's there, and you can see all the various flags that need to be set. At a very high level, once you've done that, you can say, OK, we're going to specify this remote cache configuration that's defined in the Bazel RC. You can see this host platform remote properties override flag that you have to set. It's very, very verbose flag name, but describes what it does. It says, well, we're describing the local system, but we want you to pretend that it's like the remote system so that you can set a remote cache value. So you put your cache silo key in there. You can actually do this through your workspace, through workspace platforms. But you can also do it on the command line like this. And then finally, for our particular system, we allow you to specify your particular cloud project. So this goes into your cache. It's not readable or writable by anyone else. It's all locked down. It's very secure, et cetera. Just what you'd expect. So that's remote caching. If you want to look at remote execution, as I said, it's a little more involved. The first step really is to get your build working with Bazel locally first. You can onboard to Bazel and to remote execution at the same time, but it's not what we recommend. Most people here probably are already using Bazel, so this isn't really a concern. Hopefully your build works. Otherwise, maybe you shouldn't be here. You should be fixing your build. So get your build working locally, then choose a part of your build to focus on. Get that working remotely. Get it set up under CI so that it continues to work remotely. And then you can iterate and add more parts of your build until the whole thing works, and you add it as a blocking factor on your CI, and no one can check in and break anything. The reason we recommend this, as I said, this remote sandbox idea has stricter constraints than running locally. People find that, well, that sometimes things break, so they've got to update things. Also, we recommend the CI path first here because it's the best way to really keep the system warm. and to have warm workers, to have enough traffic that you're populating and pulling from the remote cache. If you're doing developer builds, those might be, it might be just one person or two people, and they're not doing enough builds to really see benefit from the system. But with the CI system, it's sort of priming the pump for everyone. And we've found that this delivers the best speed up and the most impact if you get your CI up and running first. So in terms of this process, you want to capture your execution environment in what's called a toolchain. I'll talk about that in just a minute. And then configuring permissions and configuring Bazel, just like you do for the remote cache. So what is a toolchain? The toolchain is just the encapsulation of the execution environment where your builds and tests are going to run. This defines things like the installed software, the libraries, header files, et cetera. We use a Docker image to encapsulate this. You don't have to, but for us, it seemed like a pretty intuitive fit to say, this is what the remote system should look like. It's an easy specifier. You can specify a SHA hash, and everything, again, is very easy to follow. The only problem with this is the Docker file is kind of opaque to Bazel. Bazel has to be told about what that execution environment will look like, unlike when you're running locally, where Bazel can just look at your system and say, oh, I see you have this JDK installed and this tool installed and that tool installed. So you need to specify a cross-tool flag that says, here's some information about this remote system and where to find specific binaries, specific things. You might need to specify some JDK-related flags that tell you what's in that Docker file and how it differs from your local system, things like that. The good news is we do provide a reference toolchain. It supports C++, Java, Golang, Python to some extent. We only support native rules, not rules Python. We're working on that. So it supports a pretty wide variety of things. A lot of people have found it's pretty usable just as is. And it's centrally maintained and released by Google. So it's really the fastest path to onboarding. But let's say you work in Scala or Kotlin or some other language. You can roll your own toolchain. You can either use our provided toolchain as a base, or you can roll one from scratch. We've also seen good success with this. We've had several customers who have come to us and said, oh, I need to use this language. And we give them the instructions, and they build a toolchain, and it just works with the remote system. So although officially we have those four languages, C++, Java, Golang, and Python, we've seen pretty good adoption across other languages as well, and a pretty smooth path for that. You might also need to roll your own toolchain for other things, like if you're running integration tests and you need some specific application or credentials or something like that, using rules Docker to create Docker images, or using sanitizer sometimes requires special toolchains. Again, going back to permissions, this one's a little bit different than remote cache. So all these jobs are run on the remote workers. All the data going in and out of that system is content addressed. So you can't say, I'm going to write this file, but the contents don't match. The system will reject that. So it's actually pretty safe, and it's pretty hard to poison the cache via this. So you should let your CI system and your developers send jobs to the remote system, and then those will be written into the cache, and everyone can share those cache values. And finally, setting up Bazel. Again, lots of Bazel flags. We provide a sample Bazel RC. You can copy that and merge it with your own. The other wrinkle here is that the toolchain you defined, you have to add to your workspace. There's some well-defined Bazel rules that you have to put in there. And you have to say, OK, use this toolchain with this target. I believe it's actually called a platform, excuse me, in that case. So you use this platform with this target, things like that. And again, the command line is just you pass that remote configuration, and you pass an identifier that tells Bazel to point to your particular instance of remote execution, remote build execution. So that's a pretty high-level overview. Tells you some of the advantages of remote builds, tells you a little bit about the specific Google service and about remote builds in general. Thank you.